This is a video on break-even analysis, location break-even analysis. You did something similar to this in Chapter 7 where we looked at different capacities. And in that case, you were only looking at two capacities, capacity A and capacity B. And as is typical, the larger the capacity, the more the fixed cost and the lower the variable cost. Well, we can also use that approach in regards to location, but in this case we have three possible locations. And so normally what happens is you simply compare them site 1 to site 2 and then site 2 to site 3, going from the lowest fixed cost to the highest fixed cost, because in this case site A, so this data is from 8.18 from the end of chapter 8. We have Audi Motors, who is producing an SUV, and they're looking at three locations, Site A, Site B, and Site C. And normally what we expect to happen is that we will get a quantity here when we compare A to B that would indicate that below that quantity A is the best, the first site, the one with the lowest fixed cost. And then when we compare B to C or Site 2 to 3, we would get a higher amount than this Q, which would indicate, so in between these two numbers, the B side or the second side is the best, and then above this second number, Site C is the best. But here we have some interesting results. It's not necessary to do the graph, but when you see these results, I want you to kind of picture in your mind what the graph would look like. And what you need to do in that case, so if this second number, if you do site 1 to site 2 and you get a number, and then site 2 to 3, and that number is not larger than this number, then you know you have this issue. So this is a very unique one, and so we need to go back and compare A and C. So let me talk about this visually. I think you know how to solve this. So once again, we're comparing site 1 to site 2, and so we really want to know where they transition. And so we're comparing the lower fixed cost to the second highest fixed cost, or the next one in line. And so, of course, you know, the lower your fixed cost, the higher your variable cost. So if we compare site 1 to site 2 and solve for Q, we get a thing of 20,000. So if we didn't have a site 3, and you had to choose just between A and B, at less than 20,000, A would be the better site, and above 20,000, B would be the better site. And so we basically calculated this point right here. So you have site A, the 10 million, and then the 2,000 or 2,500 variable cost. You have site B, the second site, at 20 million. Now it doesn't have quite as high a variable cost, it's only 2,000, and so over time they do cross. The costs equal each other, and that's that this 20,000 is where those two costs equal each other. And so in this case, at 20,000, you would want to go to the second site because it's cheaper than site A. But here's where something interesting happens. When we do the comparison between that second site with its 20 million and the highest fixed cost, site C, at 25 million, so once again, a lower variable cost because there's more in fixed cost, we wind up with an amount that's lower than this. And so think about it this way. If we didn't have site A, you just had B and C, and you were just comparing these two, well then that would be 5,000. So here is site B at 20 million, and it has its line, so 2,000 variable cost, and then 25 million, and this is a very shallow, not as steep a slope, site C, and so at 5,000 their costs are equal to each other. Now that's comparing one site to another site. Now if we put all three sites on here, and like I said, we had this higher amount and then we went down, that indicates that basically site B, the site in the middle, really isn't a contender at all. Normally what happens is you have the site that's in the middle, so basically they range from the highest or the lowest to the highest fixed cost. that this slope of this line would not be as steep. And so instead of crossing, here, crossing way before A, it would actually cross much later out here. And so for a period of time, it would cross A, and then so the difference between A and B would be that point, and then later on it would cross C, and then C would be the best. And so in between those 2 points. But in this case, it goes fairly steep, and so it crosses the site C very early on, and then crosses A very much later. So that lets you know that it's higher than both of the A and the C. And so really what we need to do is go calculate the difference between A and C. So between that point then, A is the cheapest and then C is the cheapest. B has too steep of a slope, so it's not even a question. So think about this visually. If you get results like this where the second comparison, the first and second site compared to the second and third site is lower, then you know that the second site is not even in contention, and go back and compare the first and the third site. And so we will solve for that, and we get this 10,000 here. And so up to 10,000, A is the best, and then above that, C is the best. Think about it this way: that A you can go all the way to 10,000, and then C becomes the cheaper. B just is not even in the contention in regards to this. And so if you get those results, recognize the fact that that you have this very unique case where the middle, the second site, or the B site is not even in consideration. And so just make the comparison between the first and third site to solve the equation.